Good afternoon, grade 9s and colleagues. Today marks the last lesson of the week on exponents that we started on Monday. We are going to be focusing today on the power with exponent 0, as well as the power with the integer exponent. For this, we need to go back to the last part of lesson 1 that we had on Monday, where we're dealing with division. In our parting ways, this was the question that was posed. Giving 3 to the power a divided by 3 to the power a, which will be equal to, applying the laws of division of powers, this will be 3 to the power a subtract a, where the exponents are then being subtracted one from the other. And then we ended up with 3 to the power 0. This was the question that we said the answer to which will be given in this lesson. Secondly, the other question that was posed will be the second part of the response in this lesson, was that of dividing 3 to the power 2 by 3 to the power 5. In this instance, the exponent, as you can see on the screen, this exponent 2 is now smaller than 5, whereas previously we started with 3 to the power 5 instead, divided by 3 to the power 2. Now we swapped the two powers around and applied the rule. Now it's 3 to the power 2 subtract 5, and we end up with 3 to the power negative 3. And we wanted to find out what the answers to this in their simplified form would be, and that's the reason why we are meeting and concluding this lesson on exponents today. Now, when you go back to the basics of division, you'll remember that we read this statement as 2 divided by 2, which we know will be equal to 1. Alternatively, the notation that we also use would be where we indicate this as a fraction with a numerator 2 and the numerator 2. 2 over 2, which is still 1. The other classic notation that we are used to is where we use this division, the long division method, where your 2, which will be the dividend, and then we have another 2 will be the divisor. In this instance, this 2 that we are dividing by, in the notation of the fraction, will be the denominator. In the first notation, it will be the second part, is dividing, the one that is used to divide. Now, the one being divided, the dividend, is the one under the sign. And the way we do this would be, we say 2 is divided by 2 divides into 2 how many times? The answer we must indicate here on top as the quotient, which will then be, we know that when 2 is divided by 2, we get 1. Once we have the 1, now you must multiply 2, this one is the answer, by 2, so that you end up with a 2 right beneath the dividend. And then we draw a line, because we subtract every time after dividing and after multiplying until we no longer have a remainder. In this instance, when you bring in the subtraction sign, then you end up with 0. This is also the long division method that you grew to know. But then we introduced the exponential form, where we have to indicate the base and the exponent. And how does this now address the question that we had? In this instance, your 2 divided by 2 in that form is not reflecting the exponential form as requested. Now, for that to happen, we need to put it this way. Then we can divide, then we can apply the rule of the law of division of exponents. Because now you can clearly see there's your power, there's a base with an exponent, there's the base with the exponent, as well as the base with the exponent. This is in the form that we want. And the left-hand side, then we can apply the rule. With the second notation, the same thing. It becomes 2 to the power 1 divided by 2 to the power 1, which will be equal to 1. Now we apply the rule. We maintain the base, and then we subtract the exponent of the power at the bottom from the exponent of the power on top. Will be 1 minus 1. This in turn will give us 2 to the power 0, which then addresses in part the question that we had previously, where we had 3 to the power 0. When we had 3a divided by 3, 3 to the power a divided by 3 to the power a. Now, there's our answer, that whenever you have 2 to the power 0, the answer must be equal to 1. That's the answer to the first question that was posed. Secondly, in general terms, we have a divided by a. Still, in this form, it is not in the exponential form. What we do instead, we do what we did with 2 divided by 2. Then it becomes a to the power 1 divided by a to the power 1, which will be equal to 1 to the power 1. This in turn then translates into the format that we now are accustomed to of a to the power 1 divided, or rather over, a to the power 1, which will give us 1. Applying the law of division of exponents, now we retain the base a, and then we subtract the exponent of the bottom power from the exponent of the power on top. And then just like the previous example, then we end up with a to the power 0, which is giving us 1. Now, grade 9s, please be mindful at this point in time that you are now aware that we end up with the same answer, that 2 to the power 0 is equal to 1. Previously, we had 3 to the power 0, which we wanted to know what is it equal to. Now we say generally it doesn't matter what number it is here. As long as you have a number as the base with the exponent 0, the answer will be 1. Now this answers our question. It's something that we must now know, that any number raised to the power 0 will always be equal to 0. Will always be equal to 1. Now moving forward, now we continue and we apply this to the second question that we posed. I want you to think of the two notations, one being on the left-hand side and the other being on the right-hand side. We know that 3 squared divided by 3 to the power 5 is the same, or is equal to 3 squared over 3 to the power 5. It's just a matter of notation. We've seen this. Now, to prove what you wanted to prove, what happens if we are now subtracting the exponent that is bigger from the exponent that is lower. Now, we're going to focus first on the left-hand side. Applying the rule, it will be retaining the base 3, and then it's 2 minus 5, which in turn will give us 3 to the power negative 3. It's because we are applying this rule. A to the power m divided by a to the power n will always be equal to a to the power m minus n. In this instance, it is 2 minus 5, which gives us minus 3. So the answer on the left-hand side is 3 to the power negative 3. Now the question will be, what happens to the right-hand side now? Now let's look what's going to happen. Now we expand the 3 squared, which is on top, to be 3 multiplied by 3. This comes from lesson 1 that we had on Monday, where we are saying the repetition of multiplication gives us the exponents or the powers. It simply means 3 must appear twice in the multiplication. Now the 3 squared is therefore 3 multiplied by 3, and then we are dividing, and we draw this line to indicate that we are dividing, and 3 to the power 5 gives us what? 3 is repeated in multiplication how many times? 5 times. You can count. It's 1, 2, 3, 4, 5. This is what we have. Then we go the classic route of cancellation. 3 divides into 3 once, into 3 once. That takes care of the first 3. Secondly, we do the same thing, 3 divides into 3 once, and in the bottom one once. We end up with 3 more bases remaining. What do? We simplify. Your numerator remains only as 1 because now you have 1 multiplied by 1, which is 1. But at the bottom, you end up with 3 multiplied by 3, multiplied by 3, multiplied by 1, multiplied by 1, which yields us 3 by 3 by 3. This in turn gives us 1 over 3 to the power 3. Now, this is the answer on the right-hand side. And we know it must be the same as the answer we got on the left-hand side. Now, it's telling us, girls and boys, that 3 to the power negative 3 is the same as 1 over 3 to the power 3. We have now seen now how to change the negative exponent, and we end up with an exponential form, yet the exponent is no longer negative. Please keep that in mind. Secondly, we try the same approach with a different number. Now, in this instance, we're having 1 that must be divided by 3 to the power 5. We must find a way, and as we go, we apply the law that is suitable for that particular situation. I want you to focus on the 1. It is for this reason that 1 is now written in color. We've just seen now that any number to the power 0 is equal to 1. So in reverse, we are saying, oh, now that you have a 1 here, it means we can still write 1 as a to the power 0. But if we do that, we'll be having a different base now. It will be a to the power 0 divided by 3 to the power 5. Now, it's not going to help us to apply the law. Instead, we must maintain the same base. And we've seen 3 before. It was part of the quiz on Monday when we left at the end of the lesson. Now, instead of using a to the power 0, now I know you're smart enough to realize now it's 3 to the power 0 because it says any number. Now, why do we choose 3? Why don't you go for 1 or any number? Because we want us to have powers with the same bases. If the powers have the same basis, then we can apply the law of division of powers. Now we know we've placed 1 and we've written 1 as 3 to the power 0. Then we can apply this law where we do the subtraction of the exponents. Now this then becomes 3 to the power 0 subtract 5, which in turn will give us 3 to the power negative 5. Just an errata there. It must be 3 to the power negative 5 because it's 0 minus 5. What happens on the right-hand side? On the right-hand side, this is what happens. It's still 1 divided by 3 to the power 5, and this side we're doing the long root. First, change the notation to write it this way, and then we expand. It's 1 over 3 that must appear 5 times in repetition of the multiplication, but then there's no cancellation possible here. So what we end up with, we simply end up with a fraction 1 over 3 to the power 5. Boys and girls, please ignore this. This must be a 5 because we see that the 3 appears 5 times. So it's 1 over 3 to the power 5. Now it answers the question once more. You had a negative exponent, it ends up being a positive exponent. Moving forward, now we can generalize and say, whenever we have a power to a negative exponent, now we can conclude without any fear that this will always be equal to 1 over a to the power m, where the exponent is no longer negative, but it is positive. Maybe a challenge or just a brain teaser for you would be, what happens if now you have a power with a positive exponent? How then will you change that to be negative? You just twist in places here. If it's a to the power m, then it will be 1 over a to the power negative m. I think it's straightforward. I know many of you got it right. You can give yourself a pat on the back. So in conclusion and in summary, the journey we traveled this week, we started off with multiplication of powers, where we said whenever we have powers with the same basis, whether using the multiplication sign in between or just the dot, the answer will always be writing the base once and then you add the exponents. Remember that the bases must be the same and there must be multiplication. Only then you can add. Secondly, we did the division. We just repeated the division now. With the division, the watchword would be the bases again must be the same. Whether I use this notation or the other notation doesn't matter as long as we have the bases that are the same. Then in that instance, then we keep the base ones and then we subtract the exponent of the power at the bottom from the exponent of the power on top. In this regard, we are now confident. It doesn't matter whether the one on top is bigger than the exponent at the bottom. It doesn't matter. We now know what rule to use and how to use it. And then the day before yesterday, the second lesson, we were raising the powers to a power where we kept the base and then the exponents multiplied each other. We also raised the term to a power where the exponent outside the bracket had to affect and impact on every other power within the bracket. What I must highlight here and you must be aware of is the fact that you've got different bases. And because we're talking about the raising, it does not matter. We're not adding. All that happens is that every exponent that we have within the bracket gets multiplied by the exponent outside. We end up with a to the power m multiplied by b to the power n. Then we've just done the power with exponent 0. We've seen is a to the power 0 is 1. We also now know that power with the integer exponent, when it's negative, how to write it to be positive. Colleagues and boys and girls, this brings us to the end of this lesson on exponents. I know now, remember, whenever you are given an exercise, look first for the same basis. Thank you very much. This is all for today. Bye-bye.